All right, so now that you've seen the videos on transform boundaries, you've taken your notes, you've learned about the action involved, the cause of the action, and then the results from that, we're going to kind of look at some of the unusual situations. So one of those is happening in the Atlantic Ocean between the North American plate and the Eurasian plate. If we were to draw a plate boundary between two plates, it would be easy if we could just draw a straight line, but the Earth doesn't have a lot of straight lines. So we get contours, we get curves in our plate boundaries. And the Mid-Atlantic Ridge is a result from that. At that plate boundary, the divergent plate boundary between the North American plate and the Eurasian plate. So that's what your activity is going to be about. And we're going to try to relate how a divergent plate boundary can actually lead to transform plate boundaries as well. So you're going to need a piece of paper. You might use a ruler. You need some scissors, or maybe you can just tear carefully. You'll need something to write with. So let me show you. I'll kind of switch back and forth between me and the actual activity. So this is what you need to get set up. We've got our paper. We've drawn in just any kind of random lines. I used my ruler to do that, just went down a little ways and kept shifting the direction of it to give it that kind of zigzag sort of look. And you can see I've labeled the North American plate on the left side and the Eurasian plate on the right side. So again, the reason I've drawn in those different angles is because the plate boundary is not a straight line. It's got all kinds of contour to it. Each of those little bends, each of those sections of the plate boundary are called legs. So we've got 1, 2, 3, 4, 5, 6, 7 legs to what I've drawn here between these two plates. And this could be a micro little section of that actual plate boundary. Our next step is going to be to put some dots or put some marks on our paper to represent specific spots. That way we can watch those spots, track those and their movements as the plates are being pulled apart in this divergent plate boundary. So here's a look at what you should do. At each leg that we have, you're going to put a dot on one side of the plate boundary and then across it on the other side. So we've done 7 of these, 1 for each leg. At any point, if you'd like to pause the video and complete the steps, you can always do that and then return to the video when you're ready to move on to the next step. So once you have your lines drawn and your dots put in there, then we'll go to our scissors and we want to cut this into 2 pieces of paper. So want to cut this into 2 pieces of paper, cutting along each of the lines to separate them into the 2 plates that we have. So here's my completed model that I have right here. As I can show you, you can hopefully separate those apart. So these are divergent plate boundaries. The North American plate and the Eurasian plate are moving apart from each other. The prefix di means apart. Any spots that open up on the table below that would be fissures, cracks in the Earth's surface, areas where the mantle could be exposed. Well, the mantle is under incredible amounts of pressure, and that magma, the liquid rock in the mantle, would love to have the crust opened up like this and relieve some of that pressure. So any of these spots that open up would allow new rock to come up from the mantle, spill over on top of the plates, and then be pulled away from that area. And this is going to continue over and over and over. And that's the formation of ridges like the Mid-Atlantic Ridge and seafloor spreading. So quickly, let's kind of review our 3 types of plate boundaries. We've got convergent, divergent, and transform boundaries. We can see here convergent means come together. The plates are moving inwards towards each other. Divergent means apart, and our plates are moving apart from each other. And then transform means across. They are moving in opposite directions across the plate boundary, rubbing on each other as they move past. So here in the assignment, after you have your plates all set up, you've got them cut out into two separate sides. You can then move them apart from each other as a divergent boundary, and we're going to begin to draw things on the paper. So I'm going to open up my marker here. First of all, the overall movement, so draw a big arrow. The overall movement is for the Eurasian plate to move to the east, and the North American plate to be moving to the west. So right away we can see that the overall plate boundary is certainly a divergent plate boundary. The plates would be moving apart from each other, like I was just demonstrating, apart from each other. I'm trying to do that with one hand because I'm holding the camera in the other. But now your job is to go back to each of these little dots and watch which direction their movement is in, and then we can match that up with the combinations of arrows that we had before with convergent, divergent, and transform. So for example, these top two dots here, as we pull the plates apart, this plate causes this dot to move to the right, and this plate's moving to the left. So in that leg of the plate boundary, we certainly have a divergent plate boundary. But as we look here to this one, this top dot is on the North American plate, and the North American plate is moving to the left or to the west. And so that dot, as we slide them, will be moving that direction. The Eurasian plate is moving to the right. So you can see here on that spot, that leg there, that as those plates are moving apart from each other, they don't get further apart here. The plate boundary isn't opening up and allowing new magma to come up. What's happening is they are sliding past each other. They're rubbing on each other at that plate boundary, with one moving one direction and the other moving the opposite direction. So that is an example of our transform boundary. So you should be able to complete the rest of it. It's fairly simple, but what you'll notice, I think, when you're done is that all of the lines that are vertical on our paper are opening up in divergent boundaries. And then all of the lines that are horizontal, moving left and right, are having spots that are sliding past each other, rubbing on each other across the plate boundary, and we have transform boundary on all of those lines. So if you just set that up, mess around with it, make sure you understand the main concept, and we'll move on to a new lesson tomorrow. Hope y'all enjoyed that. Hope you're having a good, safe time at home. Just want to stop and share with you and tell you that science rocks. Peace.